Hi guys, good morning. Um, Welcome to my YouTube channel, Engineer Cinco from CLNP. Okay, as we studied before regarding these DC circuits or direct current circuits, what we have learned is how to solve for the current along the series connections. Okay, and the second one we also studied parallel connections regarding how to solve the current. Okay, and not only the current and also the resistance or the voltage across for every resistors and for the voltage drop across for every resistor in parallel series. Now today guys, I am giving you some example problem related to the DC circuits, okay, for series connections. So as you can see here in the above, our electrical source or the battery source is 120 volts. Okay, going to this direction because this is the positive terminal and this is the negative terminal, and the total current is given, which is zero point 0.6 amperes. Okay, or zero point 0.6 ampere, and we have here three resistors in a series connection. The value of resistance along A or this first resistor is 50 ohms, and the second resistor RB is unknown, but knowing the voltage drop across this resistor, which is equal to 40 volts. And the third one is the RC, third resistor, which is unknown. Now in this problem we are finding the voltage drop across the resistor A. Okay, second requirement is the resistor B, knowing the voltage drop. Okay, and C is the resistance. Okay, uh, fourth requirement is the total resistance for this particular circuit. Okay, and the last one is the how much power across this resistor C. Okay, P or C, or power across resistance C. Okay, so solution guys. Okay, first we need to solve for the voltage drop across resistor A. Okay, so BA. Okay, A, solving for voltage drop. Okay, solving for the voltage drop across resistor A. Okay, across resistor A, resistor RA. Okay, so using the Ohm's law. Okay, since we have already given the total current along the circuits, so using the Ohm's law, what we have learned before, Ohm's law is represent voltage or volts, BE is equal to the total current times the resistance. Okay, which is RA. Okay, so substituting the values guys for the current and the resistor, how much the current given? 0.6 ampere. Okay, 0.6 ampere times the resistor RA, which is equal to 50 ohms. Okay, so voltage drop across resistor A is equal to, let me calculate guys, um, 0.6 ampere times 50 ohms. How much? 30 volts. Okay, so there are 30 volts drop across this resistor A. 30 volts. Okay, now we already computed the voltage drop across resistor A. Then second requirement, we need to solve for RB, the resistance for this particular resistor, knowing the voltage drop. Okay, so letter B, solving for RB. Okay, solving for RB. Okay. So again, using Ohm's law, V is equal to total current. Take note guys, in series connections, the current flowing across resistor A and the current flowing across resistor B and C is the same, okay, since the connection is in series as we studied before. Okay, so resistor B, RB, okay, so it's unknown. So how much the voltage drop across resistor B, which is 40 volts given. So you substitute 40 volts, okay, is equal to how much the current? 0.6, okay, times resistor B, which is unknown, okay, over 0.6, 0.6, answer. So resistor B is equal to how much guys? 40 volts divided by 0.6 ampere is equal to 66.66 or 67 ohms. Okay, so this is the value for the resistor B, knowing the voltage drop, which is 40 volts, okay, as you can see in this diagram, because the current flowing in this circuit is constant, which is equal to 0.6 amperes. Take note guys, series connection. Okay, now third requirement is the resistor across C or resistor C. Okay, so letter C, solving for RC, okay, or resistor C, solving for RC, okay. So take a look guys, there is no voltage drop across in this RC. We don't know in the first place. Okay, so how you will solve the resistor C? You have already resistor A, you have already resistor B, RC is unknown. Okay, so RC is unknown. Okay, so again guys, to solve for RC, as you can see here, we have already the voltage drop for BA and BB, and you have also given the source, battery source, which is 120 volts. Okay, so total voltage, okay, is equal to the sum of all the voltage drop across each resistor. Okay, so BA plus B across the B resistor, and then C, which is unknown, we don't know. Okay, so we need to solve first for voltage drop across C, knowing the voltage source, battery source, okay, how it is 120 volts. So we substituting all these values, total volts, this one is 120, is equal to how much the voltage drop across A, we have already computed here, which is equal to 30 volts. Okay, substitute here 30 plus how about voltage drop across B, which is already given 40 volts. Okay, plus voltage drop across A is we don't know, so we need to find first. Okay, so 120 is equal to 30 plus 40, 70 volts plus C. Okay, so voltage drop across resistor C is equal to 120 minus 70, okay, is equal to how much? 120 minus 70 guys, which is equal to 50, right? 50 volts. 120 minus 70 volts is equal to 50 volts. So there are 50 volts drop across, voltage drop 50 volts across resistor C. Okay, now knowing this voltage drop across resistor A, we can apply again the Ohm's law, okay, to find the resistor C. Okay, so using Ohm's law again, V across resistors is C is equal to total current, okay, times the resistor C. Okay, substituting the values, which is 50 volts, is equal to how much the current? 0.6 ampere. Okay, times RC. Okay, so over 0.6, 0.6 cancel. So resistor C is equal to how much, guys? Okay, let me calculate again. 50 volts divided by 0.6 ampere equals 83. So there are 83.33 ohms. Okay. Resistor C is equal to 83.33 ohms. Okay. Now we have already computed the resistors. Now, fourth requirement, how much the total resistance for this particular circuit? Okay, letter D. Okay, solving for total resistance. Total resistance. Solving for total resistance of a circuit. RT. Okay. So RT is equal to summation of all the resistors or resistance along the circuit. Okay, which is equal to RA plus RB plus RC. Okay, so substitute, guys. How much RA? Already given here, which is 50 ohms. Plus, how much RB? RB, we have already computed here, which is equal to 66.67. Okay. Plus RC, this one, guys, 83.33. So, equals, how much? What is the total resistance of the circuit? So 50 plus 66.67 plus 83.33. So there are 200 ohms. Okay, RT is equal to 200 ohms. Okay. Okay. Now we have already computed the total resistance along this series circuit for this particular problem. Now the last requirement is we need to find the power for this particular resistor C. Okay? How much the power developed or powered A. Okay, let me write here, guys. Solving for, okay, solving for power along C, resistor or along resistor C. Okay? So, as we studied before, power along resistor C is equal to voltage drop along resistor C times current. Okay? Total current, which is 0.6 amperes. Okay? So, substituting, guys, what is the voltage drop across C? We have already computed here. Is equal to 50 volts. Okay? So 50 volts times how much the current? 0.6 ampere. 0.6. Okay? So power along resistor C is equal to how much, guys? So 50 times 50 volts times 0.6 ampere is equal to 30 watts. Okay? Unit, guys, for power for this particular circuit is watts, okay, or W, meaning watts, huh? Okay. Now, we have already calculated all the requirements for this particular problem. Okay? So, again guys, to understand further, I'm giving you another example related for this DC circuits. I will give you later, okay? Hey guys, we're back again. Now, I'm giving you now a second problem related to DC circuits, okay? Now, take a look guys with the diagram. What type of connections have you seen this diagram? So I believe this is a parallel connection, right? Okay, as you can see here. So in this diagram, we have already given two resistor in parallel connections. Okay, the resistor 1 which is equal to 10 ohms. Okay, and the second parallel resistor is equal to 15 ohms. And the total current flowing across this circuit is equal to 20 amperes. Okay, this is the flow of the current. So, if this is the total current, since there is a junction here, so current will be split into two. So, there will be a current 1 flowing in this direction, okay, I1, and the second current flowing in this direction, which is equal to I2, okay, since it's unknown, so it's also included in the requirements I1 and I2. So based on this diagram guys, parallel connections, our requirement here is total resistance. How much the total resistance across the circuit? Okay. Second requirement is the total voltage of the source or the battery. And the third is the current flowing in the resistor 1 and the current flowing in the resistor 2. Okay. So solution guys. Okay. A, solving for total resistance, okay, of the circuit. RT. Okay. So what we have studied earlier regarding parallel circuits, the total resistance of all the resistors is reciprocal from the series connection. Okay, meaning to say 1 over total resistance is equal to 1 over R1, okay, plus reciprocal of R2 which is 1 over R2. Okay guys, since the connection is in parallel. Remember, we have studied regarding the total resistance equation for parallel connection, right? So knowing this properties or the formula, we can substitute, okay, we can substitute values for the resistance. Okay? 1 over total resistance is equal to 1 over what? How much the resistor 1? Resistance 1? 10 ohms. Okay? 10. Plus 1 over the second resistor which is equal to 15 ohms. Okay? So simplifying this expression, we have 1 over total resistance is equal to, what is the common denominator for these two fraction guys? Okay, as you can see here, it's 30. Okay, we can use 30 because 30 divided by 15 is 2, 30 divided by 10 is 3, right? 20 is not possible, 25 is so 30. Okay, LCD is the 30. 30 divided by 10 is 3 times 1 is 3 plus 30 divided by 15 is 2 times 1 is 2. Okay, so 1 over total resistance is equal to 3 plus 2 is equal to 5 over 30, or total resistance is equal to 30 over 5. Okay, so total resistance is equal to 30 divided by 5. How much guys? 6 ohms. Okay? Because 5 times 6, 30. So there are 6 ohms. Correct? So 6 ohms. Okay? 30 divided by 5 is 6 ohms. Total resistance in this particular parallel circuits is equal to 6 ohms. Okay? So otherwise, let me calculate also. 1 divided by 10 is equal to 0.1. Okay? 1 divided by 15 is equal to 0.066 plus 0.1 is equal to 0.16. Okay? So 0.166. Okay? So 1 divided by 0.166 is equal to 6 ohms. Correct? So there are 6 ohms total resistance across these parallel circuits. Now, next, second requirement is the voltage, total voltage of the battery or the source. Okay, letter B. Solving for total voltage of source. Solving for total voltage. Okay. Of a source. Okay. VT. Okay. So, okay, so total voltage is equal to total current, which is given, times total resistance. Okay, so equal to total current is equal to 20 amperes times total resistance, which is equal to 6 ohms. Okay, so total voltage for the source is equal to 20 times 6, guys. How much? Okay, 20 amperes times the total resistance, which is equal to 6, 120 volts. Okay, so this is the value for the source or total voltage. Okay, okay guys, to continue further, the third requirement is how much current flowing across the first resistor, I1. This current, how much current flowing this R1. So the letter C, solving for, okay, I1, okay, or the current flowing across this resistor. Okay guys, as you can see, since this is a parallel connections, the voltage drop across resistor 1 is equal to the total volts. At the same times, the voltage drop across resistor 2 is equal to the voltage drop across resistor 1. At the same time, equal also to the total voltage drop, total voltage. So meaning to say, total voltage is equal to B1, okay? And also is equal to B2. Meaning to say, the voltage drop across this current, across this resistor is equal to the source. And also this one. So, as you can see here guys, now, to solve for I1, okay, so, V1 is equal to total voltage, okay. So, applying the Ohm's law, B1 is equal to I1 times R1 is equal to total voltage. Okay? I1 times how much the resistor R1? 10 ohms. Okay? Is equal to how much the total source? You already computed there, 120 volts. Okay? So I over 10 and over 10 cancel. So I1, okay, 120 volts. Okay, 120 volts divided by 10 ohms. 12 amperes. Okay? So the current flowing against resistor 1 is equal to 12 amperes. Right? Now, second, last requirement is the current flowing across this resistor 2. Okay? Letter D. Solving for I2 means the second current. Okay? This one, I2. There are two options, guys, on how to solve the second current across this resistor 2. You can use the total current is equal to the summation of these two currents. So total current is equal to I1 plus I2, or you can use the other way, second option, which is Ohm's law. The voltage drop across resistor 2 is equal to V1, as you can see here. Okay, so knowing the voltage drop, you can divide the resistance to find the I2. Okay, let me show. Okay, first option, first option. Okay, first way, or first first way to solve I2. Okay, total current is equal to the summation of these two current flowing across its resistor is equal to I1 plus I2. Okay, so how much the total current? 20 amperes. How much I1? We have already calculated here, which is equal to 12 amperes. Okay, plus I2. So I2 is equal to how much, guys? 20 minus 12. 8 amperes. Okay. Okay. And the second option, okay? Second way, using the Ohm's law, okay? B2 is equal to I2 times R2. Okay, how much is the B2? As you can see here, guys, is equal to B1 is equal to total voltage, which is 120. Okay, 120. Okay, 120 volts is equal to I2 times how much resistance? To 15 ohms. Okay, so I2 is equal to how much, guys? 120 divided by 15. 120 divided by 15 is equal to 8 amperes. See, guys, they're the same. So you can solve in this way, or you can solve also in this another way. They are the same answer, okay? 8 amperes. Okay. So that's it, guys. On how to solve current across its resistors, and the total voltage, and also the total resistance. So I hope you understand this example problem related to the DC circuits. By the way, guys, this is a parallel connection, ha? these parallel type circuits. So kindly like, share, and don't forget to subscribe our channel so that you mas marami pa kaming ma-share na video regarding P6, okay, under circuits. So again, thank you for watching and have a nice day.